Hi, gang, and welcome back. Or I'll say welcome back. I would say welcome to the beginning of our new series on electronics. Okay, and the purpose for this series is to take you from not knowing anything about electronics to knowing a lot about electronics. To defend you could actually basically defend yourself. Talk on electronic grounds with a fellow electronic people. And so our main goal is to take you from being a dummy to being a techie. So this is part of a series where you learn the basics of electronics, you learn how to write Arduino programs, you learn how to design PCBs, and a whole lot of other amazing stuff. But before we go jump into the big things and the the flashy stuff, we need to get down the basics down. We need to understand how electricity works, voltage, current, and everything coming together. We need to know how they function. So it doesn't really matter the background you are coming from. Yeah, we are going to take you from scratch. So you could be coming from an art background, and you will still be able to understand. You will still be able to grasp what we are, the content we are dishing out. So to get you started off with understanding electricity and electronics, I would be obliged to start with my handy material that I have here. So I'll just switch over to that, and we're going to talk about the fundamentals of electricity and electronics. All right. So we're going to kind of we're going to explain a lot of basic concepts to you. And to start with, I would like to let you know that electricity is measured in three basic you have three basic fundamental units for measuring electricity, which are current, voltage, and resistance. And they're very essential for analyzing electrical circuits. Okay, so you might be seeing this formula that says V is equal to IR, and like, what is it? What's going on here? So now, you might be wondering what that is, and now that's where this picture comes into play. So I'll just switch from editing mode. I want you to see it like as if you're viewing this document. All right. So yes. All right. So now this basically is giving you an analogy for current, voltage, and resistance. So you might wonder, what is voltage, what is current, what is resistance? I'll switch back to my circuit design and I'll show you something real quick. All right, so you see I have a battery here, and this battery is basically where I'm storing my voltage. I have an LED and a resistor. What a resistor is basically means something that doesn't allow electricity to pass through it completely. That's a resistor. Okay, now this is an LED. You find them everywhere. They are all those LED bulbs, light emitting diodes. That's the full meaning. Okay, and yeah, so this battery is what will store my electricity for me, and I'm going to tap, or I'm going to try and steal energy from this my power source right here. Right, to be able to do that, I'll need wires. I need wires to connect everything up, right? So I'll just connect it up, and I know this LED has a cathode and an anode. The anode is always the longer leg and is always positive, while the cathode is shorter and is negative. So I'm just going to take this guy like this, take it up here, and boom. Then from here, continue the circuit. I'll still explain what I'm doing. I just want you to see something happen. And back down to this guy, and boom. Now I'm going to make this one black because it's on the negative end of the circuit. So as this circuit is, if I simulate, you guess what happens. The LED comes on. You're like, why is it coming on? What actually happened here? What happened here is that a relationship occurred, or a symphony happened between current, voltage, and resistance. And I'm going to explain all that to you when I switch back to the next screen. All right. So now, so you are wondering, what is current, what's voltage, and what is resistance? So this is basically a brief. So voltage, as you can see, voltage is pushing this guy, and this guy is trying to prevent him from passing through. So it's like, what's going on? They're like fighting each other. So now this is voltage, is measured in volts. This little guy in the middle here is current, the green boy, is measured in amps, and this guy up here is resistance, measured in ohms. So voltage is your pressure or driving force. Current is the guy that it ends up doing the work. He's the one that flows through the wire and flows through your component and flows back to the battery or the power source. While resistance is the guy that tries to prevent or everything from happening. It's like It's like the load or the spoiler. It's like, okay, I'm going to prevent current from flowing. So our current will try, the voltage will force currents to flow. Resistance is like, nah, that's not happening in my watch. So, okay, now, to give you a better understanding, um, now look at this water analogy right here. See, so the voltage is the pressure, right? And the flow, the water coming out is the current, while the resistance is basically this guy that just opened here and can be closed. So that's the resistance. So voltage is your pressure, current is the water coming out, while resistance is the faucet that you can open and close. All right. So what they basically means. So let me just give you a very simple, the basic, simplest way of understanding this thing is now. If you look at this setup I have here, this guy supplies my voltage. You see here is 1.5 and 1.5. So together that's 3 volts, right? So we have 3 volts for my battery. Okay, so now my battery has 3 volts in it. Basically means the amount of pressure this thing can supply is 3 volts worth of pressure in a way. Now, and you right, so how does the current now flow? What causes current to flow? So what actually causes current to flow is, listen, electrons that move through this wire. So now I'm going to talk about something called conventional flow. So conventional flow is when electrons move or flow in a way. Yeah, they do not flow, but just so that you can understand the law, just say they flow. All right. So from the positive terminal to the negative terminal of your battery. So what we actually do is that naturally electrons want to move from the positive terminal to the negative terminal naturally. Yeah. So what we do is we deceive them, or we don't really deceive them, but we kind of help each other. So we bargain, we have a deal now with the current. We say, okay, with all the current, I'm going to provide a path for you to flow for you to get to the negative terminal. Because like, yay, all right, let's go. So you create a wire, and as the current is flowing, now you're like, I gotcha now. So now what you do is you can steal some of that energy from the battery so as current is flowing through this wire, you can steal energy from there by inserting components into the wire and causing the current to flow through it, which means you now be like, okay, I've created a path for you, right? But before you can get to the negative end of your battery, you must pass through my components, and in doing so, you must release some energy for me to use. So that's what happens here. So this voltage will force this current to flow through this place, and by the time it hits this guy, it will drop some stuff. This resistor will take some, and then this LED will take some, and then the remaining will go back to the negative end of the battery. So, and then we can easily measure that using something called a multimeter. So let me just pull up my multimeter right here. So yeah, so this multimeter now I can measure voltage and current inside this circuit. So let's say I want to know I want to measure the voltage across this resistor's terminal. So let's do that now. So, and I want to know like how many volts is each resistor consuming for my circuit. All right. So I'll make this guy red. All right. So what I want to actually do is I want to know how many volts each resistor is consuming, or how much energy the resistor is consuming. Then I can check to see that by basically, let me do that there. So if I start running the simulation, you can see that the resistor is taking 630 millivolts. That's about 0.6 volts, right? Let me see the current, and the current it is consuming is about 136 milliamperes, right? Or actually, from what I've seen, this LED actually ended up blowing. Yeah. Okay, I know why. That's weird. So the LED ended up blowing because when I switched to measuring current on my whenever I switch my ammeter to current mode, what actually happens is that this ammeter creates another circuit within itself, so it bypasses its resistor completely. So this is the amount of current flowing in the circuit now. Yeah, so it's not really concerned with the resistor anymore. But what I'm concerned with measuring is the voltage. So now what happens here is that when the voltage was flowing through this circuit, these two components took something out of, they are tapping energy from this circuit. So in a way, they are tapping both voltage and they are tapping some current too from this circuit, right? So Now, this circuit is a series circuit because all the components are arranged in a straight line, meaning that current only has one way to flow through this particular circuit. So it will be called a series circuit, right? And so yes, we can see that the voltage that this resistor is dropping is around 630 millivolts. You don't need to really worry yourself too much about that. We're still going to look into measuring voltage, and this is later. I just wanted to show you something there. Now let me just stop my simulation, and I can also measure the voltage across the LED. That should also be very straightforward. All I do is just tap here. I'll put this guy in one and I'll delete it, so delete that line. So drag this guy over here, and I can just say put one here. Other guy, put on here, here, and I put on here. So if I run my simulation and put it on voltage, you can see this LED is taking about 2.32 volts. And if you add those two voltages together, you're going to end up with the total voltage that this battery was supplying, which is about 3 volts, right? So you might not really understand what just happened now, but not to bother yourself, because it's a bit more. We're going to look into measuring voltage and current later. But I just want you to understand, right, that voltage is the potential difference or the driving force behind the circuit. Is basically what drives the current. Now, the current is basically electrons that are flowing through, trying to get from the positive end to the negative end of the battery or of the power source. Now, the speed or the rate at which those electrons flow is what is called current, and that is actually what does the work in your circuit. So if current doesn't flow, you do not have any power output in any of any form, if current does not flow. And for current to flow, your circuit must be complete. Okay, so when I mean a complete circuit, I mean there must be a path for it to actually complete. So if there's no path for the current to move from the positive to the negative, it won't flow. That's kind of the basic criteria for currents to flow. There must be a path that allows it to return back to the negative end of your battery. Now, let's go back to my little PDF here. So if I've explained, you understand this picture and you understand this analogy here, saying that the voltage is the pressure while the current is the amount of the water coming out per second and all that. So yeah, we said voltage is the potential difference between any 2 points in an electrical circuit. We already defined that, and here it says it represents the force that drives the electric current. All right, you said that too. Unit of voltage is V, and apparently Alexandro Volta was the guy that discovered it. And they gave an example here. They said the battery has a voltage of 9 volts. This means that there is a potential difference of 9 volts between its positive and the negative terminal, meaning that the amount of force that is going to drive any current that is flowing in that battery is going to have, that's basically 9 volts worth of force is going to drive electrons in that particular, if you connect that battery to a circuit. Yeah, so you said current is the flow of electric charge to a conductor, and it represents the rate at which charge flows. When they say charge, you basically mean electrons. Yeah, so you don't worry about what electrons are. Electrons are basically part of an atom. We all have electrons flowing through us, basically, but never to, they are charge carriers, basically. So never to worry yourself about that either. Now, you also see what resistance is. I say resistance is the measure to which a material or device opposes the flow of electric current, like I said initially. So, yeah, those are the 3 basic concepts you need to understand. Now, the last thing we're going to talk about today is Ohm's law. And Ohm's law is a fundamental principle that relates current, voltage, and resistance. If you remember, the initial formula I said, you saw up the way, I said V is equal to IR. So that's Ohm's law states that the current flowing through a conductor is directly proportional to the voltage across it and inversely proportional to the resistance. So now let us go back to our little kini here. So now, remember, what did he say? That he says that the current is directly proportional to the voltage and inversely proportional to the resistance. So guess what? If I want to increase the current flowing through here, which is basically to increase the brightness of this LED, what do? I can either increase the voltage or reduce the resistance. So you see, directly proportional to the voltage, meaning if I increase this voltage now, I will increase the current. So let me do this. Let me just do boom. Let me increase the voltage to 3 batteries. Yep, you see, current has increased to the point where it burns out. In fact, to show you that the current actually increased, let us measure the total current in the circuit now and do this. Put one here. Okay, no, just let me not put it. Let me not put it there. Let me put it here and here. All right, so now I can measure the total current in this circuit. All right. So and to do that, let me make this guy black just to not to confuse anybody. And make it black, please, blacky. All right. So all right. So now let's check. Let's start the simulation. So the voltage is around 4 volts. Yeah, I mean, adding up the fact that so we are seeing our 4 volts, 4.3 volts to be precise. Now let's check the current. Yeah, we are seeing 3 amps of current. Yeah, 3 amps of current. That's what this battery is supplying. And I want to check. The that's basically the total current flowing in this circuit currently, 3 amps. Yeah. Now I am going to check the total current. Wait, how do I stop the simulation? Now what I'm going to do is I want to increase the resistance now to say, because I know so that I don't want it to keep burning out. So let me just, I can actually run the simulation while I do that. So let me just increase this resistance to, let me say, 500 ohms. I don't want it to stop. So okay, yeah, the burnout has reduced. So back to my resistor. So now I want to play with this resistance a bit. So look at what happens now. It's burnt out. And remember Ohm's law. What Ohm's law states? Ohm's law said the current flowing through a circuit is directly proportional to the voltage and inversely proportional to the resistance. Meaning that if I reduce my resistance, I will increase my current, which is basically what is happening. Now let me increase my resistance. So 100 ohms, and I see my current has dropped to the point that the LED doesn't burn out anymore. And the voltage is going to be divided across these 2 components, basically. We have. So now let me I can measure the voltage without, because the voltage I'm currently measuring is total voltage output. So I'm going to try and see if I can measure the voltage. I can't delete this stuff. All right, so let me try and run it again. Even though so I'm seeing 4.5 volts total from these 2. So this is 1.5, 1.5, 1.5. So that's 4.5 volts total. So that's pretty correct there. And Control Z. So let's run it again. 4.46. So some voltage has been lost due to the fact that we've loaded the circuit with components. Okay. So now I hope you kind of understand, or you have a basic understanding of how voltage, current, and resistance kind of have a role to play in any electrical circuit. And yeah, so now before the next class, we're going to talk about series parallel circuits. So this currently is a series circuit, and they have their characteristics. So we're going to talk about parallel circuits and the characteristics of a parallel circuit and how they behave. Now but this was just so that you have a basic understanding of current, voltage, and resistance. So yes, thank you very much for staying with us, and I hope that with that you kind of know what current is, what voltage is, and what resistance is, and you can explain them to somebody in a way that they will understand. I will see you in the next class. Until then, stay good.